Okay, so let us start the second class. We are discussing about the concentric circular method, and already we have discussed the 2 or 3 steps. Now, what is the important thing is when to stop. That was in the question, and there is another question from your end was that if there is a mismatch in bit length, that is also a question. That data sequence we are given, they have a same length, so no problem. But if there is a mismatch or there is a mismatch in their data sequences, then what will happen? So I will give the answer for that. So before that, we are going to the last step. How I am telling this is the last step that I will discuss. Concentric circle method. So we are on the 4th step of concentric circle method. So this is one circle. And this is another circle. So 2 circles are there. So now see why I am telling this is the number 4th is the last one, because see the position of the circle. So this is the first position. If I take up the first bit, the first bit position has not been changed. So this is x1 0, no problem. This one was what? x1 1, no problem. This one was what? x1 2, and this one was x1 3. So after 2 rotations, what is the position of the inner one? After 2 rotations, the position of the inner one was actually this is the position of in the last, that number 3 rotation. This is the position of x22. x22. This is the position of x21. This is the position of x20. And this is the position of x23. This is number 3 position. I am not, this is the number 4 position. So now it will be changed. And what will be the changed one? If it is rotating anti-clockwise, 1 unit shift, then what will be the position now? This will come here. So this will be x23, the new position. This will be x20, the new position. This will be x21, the new position. And this will be x22, the new position. So now carefully imagine, if there is the 5th rotation, that is the number 5 circle, what will be the new position? Anybody? Fifth rotation is number 5th. It will be x20.
Same position.
Here, this will be x. This will be what? x23. This will be what? This will be what? x22. And this will be what? x21. So if you will see the first arrangement position, you will see this is the first arrangement position. This will be the first arrangement position. This is x2 0, this is x2 1, this is x2 2, and this is x2 3. So if we see about the y of 0th position, this will be the y of 0th position again in the 5th term. So that's why we will stop in 4th term. Understand? Understand?
Yes, sir.
Okay. So how we will understand that we will stop here? That is the reason. So now the position will be like this. So this will be what? This will be x2 3. This will be our x2 2. This will be x2 1. And this will be x2 0. So this will be the position. So what are the values? The values of x2 1 is equals to how much? 3. The values of x2 2 equals to 5. The values of x1 3 is equals to 7. The values of x1 0 equals to 1. And the values of here, that is x2 3. What is the value? The values is equals to 8. x2 2 value is 6. x2 1 the value is 4. And x2 2, x2 0 equals to value equals to 2. So what will be the value of y of 3? The y of 3 value will be 1 into 8 plus 3 into 6 plus 5 into 4 plus 7 into 2. So that will be 8 plus 18 plus 20 plus 40. So that will be 60. Now there will be a note: by rotating the inner circle by one more step, results in original or first data sequence. Stop. Hence, convolution process can be stopped. Therefore, the circular convolution becomes, therefore, the circular convolution becomes y of n equals to 84, 92, 84, 60. And the length of the convoluted data sequence is 4. Okay. So everybody understand this? Hello. Hello. Am I audible?
Yes, sir, understood.
So this is the concentric circle method for performing circular convolution. Now circular convolution has another method, and that is called matrix method. And there will be another question that you have asked, is that if there is a mismatch in data sequence, what will happen? So we will talk about these two things. Just a minute. We will talk about these two things. The matrix method of performing the circular convolution. Let us do that. And there I will describe you how to do that thing. Okay, so I go to the next part. Today is 11/01/2022. So matrix method. Circular convolution. So we have two data sequence. What are the two data sequence? X1n equals to 1, 3, 5, and 7. And X2n equals to 2, 4, 6, and 8. So these are the two data sequences. And same data sequence, what we do in the concentric circle. And we have to perform this convolution using circular convolution using matrix method. So what we have to do? So for matrix method, what we'll do, we'll take two matrices. Okay, we will take two matrices. What are the two matrices? Let us see. This is one matrix. This is called the first matrix. And this is the second matrix. Two matrices will be taken for 2 bits. The single matrix will consist of the first bit. That means the value is x10, x20, x30. Sorry, very sorry. X10, x11, x12, and x13. This will be single matrix. And the fourth matrix, first matrix, that has some arrangement quantity. That means, how will be the arrangement? It will be x20, first one. Now it will be x21, that is the second bit. Now it will be x22, that is the third bit. And now it will be x23, that is the fourth bit. So 1, 2, 3, 4, 4 bits are there. Now what will happen? Now there is an arrangement quantity. What will be the arrangement quantity? Arrangement quantity will be like this. It will be x23. It will be x20. It will be x21. And this will be x22. That means what is happening? What is happening? This one is, if I draw a straight line, this one is going to this side. This one is going to this side. Is shifting. And each of the bit is shifting downwards. How? Like this. Like this. Like this. So that is the shifting procedure. Understand? Understand?
Yes, sir.
So now what will happen? This last bit will go to the upper side. So this will be x22. This will be shifted down. So x23. This will be shifted down. So x20. This will be shifted down. So x21. Next again, x21 will be upper. Then will be x22. Then will be x23. Then will be x20. then what will be next bit will be there? No, because again, if I shift the next bit, it will be same as the first bit. You see here, if I give x2 0 here, then x2 1 will be come down, x2 2 will come down, and x2 3 will come down, which is the repetition of the first bit. So I will stop up to this. So again, the arrangement is very simple. What is the arrangement? The arrangement is very simple. It will go up and this will go down one by one, like this. Like this. Shifted. Again, it will be shifted up and then all will be shifted 1 unit down. So that is the procedure of arranging the bits in the matrix method. So clear, everybody?
Yes, sir.
That will give you the result of the new bit, that is x30, x31, x32, and x3. So according to this, let us put the values. According to this, let us put the values. So this implies, if I put the value, what will be implies here? 1, 2, 4, 6, 8. So 8, 2, 4, 6. 6, 8, 2, 4. 4, 2, 4, 6, 8, 2. So again, it will be repetition 2, 4, 6, 6. So this will be the end, the matrix. Now it will be multiplied with the first, second matrix. That is x1 of 1. You have to put the values. That means 1, 3, 5, 7. Now what will be? There will be multiplications, row column wise multiplication. So 2, 4, 6, 8 will be multiplied first with how much? 1, 1, 1, 1, 1. Then it will be plus. Next will be what? 8, 2, 4, 6. What will be this multiplied by? 3, 3, 3, and then 3. Then what will happen? This will be added with what again? 6, 8, 2, 4, 6, 8, 2, 4. Now 6 will be multiplied by 5. This will be multiplied by 5. This will be multiplied by 5. This will be multiplied by 5. Again plus, 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 plus. Plus is 4, 6, 8, 2. So this will be multiplied by 7. This will be multiplied by 7. This will be multiplied by 7. And this will be 7. So you will get the same answer that is given 84, 92, 84, 92. Then what will be 84, 60. Okay, everybody?
Yes, sir.
Now, what is the important thing that you have asked? That if there is a mismatch in bits. So if there is a mismatch in bits, you have to add 0 at the end of the bit to make it same length. This procedure is called zero padding. Okay, this procedure is called zero padding. If there is a mismatch in bit, it will be added with zeros in the last. So this is called zero padding, and zero padding will be used there. Like if you have a 2 sequence, if you have 2 sequence, like if it is 1, 2, 3, and it's one end, and another signal is 2, 3, 1, 4. Then how to? There is no similarity. So what I will do, I will zero pad with the first sequence. 1, 2, 3, 0. And x2n will be 2, 3, 1, 4 to make it a sum. So this procedure is called zero padding. This zero padding will be at the end of every bit. Means before zero padding is not required because it has no sub value. It will be always after. Okay. Understand?
Yes, sir.
So that is the procedure of circular convolution. So we have done it by matrix method as well as concentric circle method. So I hope nobody has any problem. Now, before going to the section convolution, we will discuss about something which is more important. So these two things must be learned by you because there is a need of these equations. Okay. It is a little bit theoretical part, but actually it is very important part. It is called representation of a discrete time sequence, DT signal, as summation of impulse. A discrete time signal can be expressed as summation of impulse, and this concept will be useful to prove the response of the discrete time LTI system. And like here, the response of the discrete time LTI system can be determined using discrete convolution. What I am telling, let Xn be a discrete time signal, DT signal. No problem. Delta N be unit impulse. And delta N minus M will be delayed impulse. Delayed impulse. Okay, so let us take this approximation. Now, we know that delta N equals to 1 at N equals to 0. At equals to 0 when N is not equals to 0. So delta N equals to 1 at N equals to 0 and equals to 0 when N not equals to 0. And delta N minus M equals to 1 at N equals to M and equals to 0 when N is not equals to M. We can write this. Can we write this?
Yes, sir.
So there are 3 minutes left. So please give your attendance for the second class. I think 6 students are there. So in the chat books, please mention your name. Now also one student has not given their attendance. But yes, now it is complete. So thank you. Now, if we multiply the signal xn with the delayed impulse, that means delta of n minus m, then the product is non-zero only at n equals to m and 0 for all others values of m. Also, at n equals to m, the value of product signal is mth sample xm of the signal xm. So we can write x of n into delta n minus m equals to x of m. So up to this, because we have less than a minute, we'll explain it into the next session. So anybody, any doubt?
No, sir.
Okay. So thank you for being in the class, and we will meet again in the next Monday, next week.